Friends, this is the solar system that we are going to talk about, and my email ID is there. So if you would like to take it down, feel free to communicate with me. So let us begin and tell you that our Milky Way, the home where we live, is something like a big patch of light which you can see sometimes going from south to north as this particular band. Okay, and our solar system is in this particular band somewhere, which I will come to very shortly. This particular picture, that the earlier picture that you saw, was actually our solar system as seen in one particular direction. But if you want to see the entire sky, then this is how the picture of solar system looks from south to north. And this picture is made using what is called the all sky camera. And this all sky camera is actually nothing but a simple concave mirror, okay, on which is kept upside down, and then using these three arms on top of it, a camera is placed. See, there are two ways of making all sky images. One is to use a 180 degree. 180 degree is large, but something like 160 degree, 140 degree lens, and then you look at directly upwards and see, or you can have a mirror projection like this. So what we see here is that there are areas where you do not have too many stars, and there is one particular area which has a large number of stars. And when people didn't know about it, people have associated this particular patch of light by some kind of a river flowing from one direction or other, or celestial river. See, we call it Akash Ganga, then it is Milky Way galaxy, and other civilizations have very similar names for it. But this is the place where our solar system is situated. Now, if you could go out, this is not the picture of our solar system, but if you go out quite far and in the one direction of the solar system, then our one direction away from the solar system and very far from our own galaxy, then looking from top, our galaxy looks something like this. You know, it's a spiral kind of a galaxy where there is a central, it's a budge in the center, and there are a lot of arms which are coming out, spiral arms which is coming out, as if it is rotating. And yes, it is rotating indeed. So this is how it looks. Now, one may ask this question, that how do we know that our Milky Way galaxy would look like this if you go far away from Earth? Then the answer is very straightforward. That answer is that astronomers over past 400 years or so, or at least 300 years, have been observing the sky regularly using various equipment. That is, initially there were photographic plates. Now we have a CCD camera, electronic camera as you have in your mobile. And they have taken large number of images of various objects in the sky and found that there are certain types of objects, and possibly our solar system, our Milky Way galaxy should look like this. Okay. If you go, I mean, this is looking from top, but suppose you want to look at this galaxy from this side, then how it looks like? It looks like this. Okay, a very flat disk, and it is bulging in the middle. Many a times, particularly when I was in Bangalore, and now, of course, this food item has become common nearly all over the world. And I used to say that it is like a big dosa, which is sandwiched between two giant idlis. So it is a big dosa is between two idlis. It looks Milky Way Milky Way galaxy, something like this. If you now, I must also tell you that if you look at the size of this Milky Way galaxy, it's enormous. You see, from one end to another, this Milky Way galaxy is something like 100,000 light years. So it takes that much of time from one end to another for light to go, about 100,000 years. But if you take the thickness of this galaxy, which is much too short, you can see it's about 300 light years. So you can say that as a when astronomers started talking about the nature of our universe, okay, philosophers started about nature of universe. So that happened about 3000 years ago, and we are now. So you can sort of make this that they started talking about it then when they were somewhere here, and now we are at bottom end of it. So that is how our Milky Way galaxy looks. Now, Milky Way galaxy has some other objects. That is, there is a central nucleus, which is right in the middle of the galaxy. Okay. Then there is a bulge, as we were talking about. So there is a nucleus inside the nucleus of the galaxy, and then it is bulging on top of it. Then somewhere here, about 30% from here, 30,000 light years from the central part, this is where our Milky Way galaxy is located. Now, once again, we can certainly say that this is how our Milky Way galaxy would look like, because you have surveyed large number of galaxies, and possibly our Milky Way galaxy is also like that. But to be even more technical, what astronomers have done, that suppose our solar system is located somewhere here, so they found different ways of measuring distances. Now, if you look at in this particular direction, which is where our Sagittarius and Scorpio constellations are in this direction, okay, that is the bulge, central bulge, or the center of our galaxy. And then there are these other arms. So what I wanted to tell you is that astronomers have actually made the distance estimates and found that yes, there are stars which are aligned like this. Of course, please mind that this is not the picture of our Milky Way that I am showing. It's some other galaxy. It is in galaxy, I think, M33 in constellation Triangulum. So this is the galaxy, but this is the astronomers have done this particular exercise to find out, and it suits. For example, they didn't find any star in this region, so this is definitely a void, but you see some objects here, and plus gas and dust. So having said that, so let us see how our solar system possibly started, or what made it start. So there was a big cloud of gas with hydrogen and helium and lot of dust in it, and it was a kind of a floating gas. Okay, but for some reason something happened, and it triggered what we call the collapse of this particular cloud. That is, it started collapsing. Collapsing means it has started shrinking. So when it started shrinking, okay, the size of it was approximate. Size of such cloud is put something like 1 to 2 light years across. So that is, light would take about 1 year to 2 years to travel from one end to another. Now, this is the model which I am showing, which is for our solar system, but this is the same process by which other stars are also born. Okay, so then over about 100,000 years, the competing forces. So what are the competing forces? As the cloud was shrinking, so it was shrinking due to gravity, because after all, gravity is attractive force, so it is shrinking out of gravity. But gas pressure, as it builds, a pressure builds, then there is a magnetic field, then also as it contracts, it starts rotating. So rotation and all these things put together, what it did was that it caused this nebula, which is more or less spherical, it started spinning. Okay, and it started spinning into what is called the protoplanetary disk, and and it shrunk to something like 100 astronomical units. Now, what is a 100 astronomical unit? As one astronomical unit is a distance between Earth and the Sun, and we will come to it little later. Okay, so this is how it happened. It started becoming flat, and then it started rotating, and it becomes about 100 astronomical unit. So now, so what you see is that solar nebula has already formed and extended in the rotating disk. So first it compressed, and then as it started rotating, it started spreading out. Now remember that in this case, what was happening is that potential energy is getting converted into kinetic energy. That means it is becoming hot and hot. And also, when you compress something angular momentum is conserved. So as it started condensing, it also started rotating fast. And when it started rotating fast, the centrifugal force is started spreading out. Okay. Now I told you that 101 astronomical unit is 1.317 or 1.32 light minutes. So 100 astronomical unit is something like 832 light minutes, which comes out to be something like 13 hours, 15 minutes, and 42 seconds. So what we are trying to say is that light takes approximately 13 or nearly 14 hours to travel from one end to the other. So that is the size of this nebulosity. And to put this in perspective, the Neptune is something like approximately 13 astronomical unit. So you can see that is the solar nebula is approximately 3.3 like this. Okay. So now as it started condensing, what happened later on was that various places things started accumulating. Small, because after all, when it started rotating, when the two things came together, they coalesced and found a slightly more gravity than otherwhere in the neighboring region. Then it would contain some more, and things started coalescing at different points. And in the central part, the gas started heating up. The central nebula, the nucleus, the center of that nebula, started becoming hot and hot. Okay. And this is what the dense, it is called the protostar, or that is a star which is about to be, or material which is about to become star. And here, what we call that hydrogen fusion has not yet started, and we will see that. We'll come to that later. So here, then what happened? That eventually, what is called the hydrogen fusion, that is two hydrogen atoms getting together and make helium. And in this process, it would leave out a certain amount of energy, and that is the fusion process, in which the star is ignited and the star is formed. So now this particular nebulosity, which started many years ago, has condensed and formed into a now star, and various places the material started condensing at a different location. Okay, and finally this picture emerged that there are this different material which condense at what we call them now today as planets. Okay, looking at the same thing from top, what you see is that there is a sun in the middle. There's a lot of material rotating around. Okay, then it started coalescing and condensing, and finally you have a sun in the center, and then these planets which are rotating around it. Okay, so now let us summarize that we have this conservation of angular momentum demands that contracting and rotating cloud, okay, must spin faster as its size decreases. Second thing is, eventually a primitive solar system comes to resemble a giant dosa, and then a large blob in the center would ultimately become the sun. Okay, so now here we come to the sun. So that is how the solar system was formed, and let us talk about the properties of different objects in the solar system. Now this is the sun. So, my dear friends, I would also like to point out to you that these are some kind of exercises which you can ask your students to do. Just to tell you that in last 2-3 days, I have been talking to professors and people from Mumbai University, and just now I have come back after a meeting with the professors of St. Xavier College. And here, what we were discussing is that what kind of projects we can give to the students, whether they are school students or college student, or even general public who is interested in astronomy. So what you see here is that it's a image of the sun which is taken in infrared, and this is very different picture than what one would normally see. I will show you a picture of sun in the next section, that how it looks. But what I'm trying to point out is that this sun is a very active place where a lot of flares are taking place, a lot of material which is coming up. And then when you talk about what height or how big this material is, and this is very many a times when I do this classroom exercise, what we do is we take a pause, ask the participant or one of the student to actually measure this diameter. Now, with a linear scale, so using a tape, you measure the diameter, and they know the diameter of the sun is something like, well, there's a small change here. It is 13 lakh 92,000 kilometers, but okay, 13 lakh 90,000 kilometers is the diameter of the sun. Now, if you have measured this and have measured it exactly 100 centimeters, then you can talk about what is the 100 centimeters. So, how much is 1 millimeter? And then you find that actually, we know many a times you have been, we know that sun is about 108 times larger than the earth is. So, you can talk about, so suppose you made this particular exactly 108 centimeters, then earth size is just 1 millimeter. So this is just a 1 millimeter size that earth we have on the screen. Gives you a kind of a feel that how big the sun is and how small, insignificant we are compared to this giant ball of gas and cloud, which is all giving us energy. So the student can be told about this. But after sun, let us go to the sun. We will not dwell too much of time, but let us talk about Mercury. Uh, Mercury, Venus, Earth, sorry, Mercury, Venus, Mars, Jupiter, and Saturn are the objects which have been known to humanity from prehistoric time. These are the objects. We call them Graha, whereas Greeks call them planets. A planet which mean actually wandering stars. And why the wandering star is that if you look at the sky, then entire constellation, sky and the night sky, with large number of stars scattered here and there, all stars maintain the same relation with each other, that is distance. So if you make a pattern of pattern using some stars in the sky, the pattern remains just like that. It doesn't change, except that the pattern would rise in the east and set in the west, or if it is in the north, there are some pattern which rotate around the pole star. You know, Saptarishis, a very famous constellation with the seven sage stars, which have seven names of seven sages. Okay, so they go round and round the pole star, but the pattern has not changed. Whereas these five objects and plus moon and the sun, their position in the with respect to these stars continuously keep changing. And we didn't know why this is changing. And Greeks said they thought that these are some kind of a stars which are wandering around, and they called them as wandering stars, which meant planets. So they got their name planet. And then they started naming various planets. Okay, and then this is a Mercury, which is a Roman god of commerce, okay, travel, and thievery also. Okay, so this god is a god of thieves. Okay, so why they might have called this commerce and travel? You see, again it comes down to the need to know basis, that when people were traveling from one place to another, they needed to know the direction. Now during the daytime, you follow the sun. You know approximately it rises in the east, sets in the west. So if you are following, you know it's what is a noon and so on, because noon it is almost overhead and things like that. In the night you have pole star which you can identify. But if you are going to start traveling, particularly early in the morning, because you don't want to travel during the hot sun, okay, so you would probably start your travel just at the time when the sky starts becoming visible. Okay, daylight just comes in. It's a dawn or pre-dawn sky, and this object is always seen very close to the sun. So possibly this particular god, the Mercury or Buddha as we call it. Okay, so it is seen close to the sun. So possibly this must have been the goddess of the goddess of or god of the travelers and commerce and so on. It moves quite quickly. In fact, interestingly, this in Farsi, it is also called Tir. I suppose the same has a meaning, the T which is moving very fast. Okay, so it is called T. Then the next planet is Venus. It is it's a beautiful planet. Actually, today morning or tomorrow morning, today morning I saw it, yesterday I saw it, and tomorrow morning, if you get up by about before the sunlight or before the sun, and then just take a walk in the eastern direction, well above the horizon, Venus is these days shining brilliantly. I mean, even if there is a little bit of sunlight, and if you concentrate, you can't miss it. And if you get up little more earlier, say about 40 minutes before the sun rises, then it is brilliantly shining. You can see it shining brilliantly above the eastern horizon. Now, talking about Venus, it is an amazingly beautiful object and shines very brightly, and it is also known to cast shadow. Now, now the moon has gone into the morning sky. But if friends, if you would like to do a small exercise by yourself and to check it out, after the new moon, moon is over few days from now. What you can do is you can do a very simple experiment. Take a shuttlecock box, okay, empty shuttlecock box. On one side of the box, you put a vertical stick. Okay, it could be pencil, pen, or something. Other end of one end of the shuttlecock box, and the other end you put a say tracing paper, and then you take it out and point this small instrument of yours towards the Venus, and if the sky, if your local ambient brightness is low, it's fairly dark, then you can actually see the shadow of your pencil on the tracing sheet. That's the kind of this planet. This is a brilliant, bright planet, and it can be seen during the daytime if you know where to look for it. So one of the simple thing which I will tell you how to look for it is that if you have a nice telescope and it is what is called the equatorially mounted, or we will talk about it later on if necessary, or if you have a telescope which you can take, you can ask your student to completely follow, and then you will see that even after the sun rises, you can look at Venus. And I will tell you this thing that last since 1980 or so. That is why I'm telling you 1980 is that 1980 was the first annual total solar eclipse which was seen from Indian peninsula in 1900s. So that was the eclipse took place, and that is where that is the time when my interest in astronomy, as you heard, started taking shape more and more. So I was told that you can see Venus during the daytime, and I attempted without any instrument, even with the naked eye, I could follow, and then it has become my habit to look at Venus during every year, and since 1980 till today, almost not almost every year I have seen Venus at least once in daytime in all these years, so I could spot it. If you have a very clear blue sky, you can easily spot, and there are tricks how to spot it. If you're interested, you please tell me. I will be happy to answer. Okay, now because this is a beautiful object, Venus has been identified as a beautiful woman, and as it is shown in this Greek statue, Venus is a female. Okay, and Venus also shows you the phases. One of the projects which I will deal with later on is to make a simple telescope, and this kind of a telescope, if you make, you can actually make out the phases of Venus. With a small telescope, 1-inch telescope with a slightly longer phase, you can make out the phases of Venus. Now, Venus also has another property that when Venus generally has the same brightness, but when you see phases of Venus, when Venus is large in size, it is crescent, and when it is smaller in size, it is seen completely near circular. And we will come to that. It's a very interesting phenomena. Okay, but before we proceed, I just wanted to also point out to you that all features on Venus are named after women. Okay, there's only one feature which does not have feminine name, but it has all features which are named after women. And there is a plateau called Phylum, sorry, which is called Lakshmi Phylum, which is named after not the goddess Lakshmi, but a scientist in US, so it was named after her. Now, Venus and Mercury, they orbit inside the orbit of the Earth. Okay, and when they are inside the orbit of the Earth, so naturally we do not see them in opposite side. They are always close to the Sun. And what you see here in this particular picture is that you will see them either rising before the Sun, as these days Venus is rising before the Sun, or you will see them after the Sun has set. But without, though I have told you that Venus can be seen during the daytime, but normally, if you do not know, then you can see Venus close to the horizon, Mercury close to the horizon, but easily it is not visible to everyone during the daytime. So they orbit inside the orbit of Earth. Now, many times you find it difficult to explain this phenomena, and so for that, what I use is that you remember the farmer has a sling. There's a long rope with some kind of a packet on the other side which has packed in the stone, and farmer rotates that, okay, around its head, and where to shoo away the birds. So if you see from a distance, then what do you see? That end part of that sling always remain closer to the farmer. Okay, it doesn't go beyond. But as far as the farmer is concerned, it rotates around his or her head. So often I give this particular example to my students, that this is how you can visualize that Venus and Mercury orbiting the Sun, and because now you are close to the Sun, so Mars, Jupiter and Saturn, they orbit beyond the orbit of Earth. Okay, how much their angular separation? You can see here that Mercury here is at the maximum angle is 28 degree, and Venus is maximum angle is 47 degrees. Now, if you talk about 28 degrees and 47 degrees, you can imagine that sky moves 15 degrees per hour. So here you can make out that if you can see Mercury and Venus only after the Sun has set, so this makes it something like less than 2 hours. You say divide by 15, so the Mercury is normally visible for just about an hour or so after the sunset, because soon after the sunset there is some kind of a light and you can't make out Mercury. So once it becomes dark, so Mercury is generally seen for about hour and 15 minutes or so, whereas Venus can be seen almost for 3 hours. So that's a long period of time when the Venus is visible above the horizon. Now one conception or one point which were often talked about, but now I was told that it is not true. And the point was that Copernicus never saw Mercury. Copernicus, who talked about Sun being center of the universe, because that is what the universe they knew. So Sun being at the center of the universe, and planets are rotating around it, which is what the theory Copernicus gave. But Copernicus himself never saw Mercury. But I was told that that is not true, because where Copernicus was in Poland, he was living. He supposed to have documented observations of Mercury. Okay, so now talking about the phases of Venus, and which is same true for Mercury also. So this picture tells you that this is an old drawing. Okay, so what it is telling you is that looking from Earth, this is how Venus is rotating around the Sun. So here, which is exactly on the opposite side, because it is far away from Earth, so it looks smaller in size. Or take this picture also, it is far away, so it looks smaller. As Venus comes closer and closer, that is how the Sun would shine on it, and then we start seeing phases of Venus. And then as it proceeds, we start seeing Venus as gibbous and gibbous, and then when it goes on the other side, its size becomes smaller, and then of course it goes behind the Sun. Now this is where I would like to share with you a very interesting historical aspect of it. Many of you have known about Galileo Galilei uh, looking at Jupiter and finding its moon, and which he used for talking about the moon sorry, Jupiter's moon, as the moons of Jupiter going around the moon, so must planets be going around. Okay, that was the argument he gave. But someone had asked, this is a historians debate about it, someone had asked him, or someone has suggested, probably it is his possibly his student had suggested it, and that is that if planets are going around the sun, then we must see its phases also. Like in this is a Copernican system, what you see is that if one is this position, you see a Venus something like this, then like this, then it is full, then again it is full at this position, nearly full at this position, then it is half illuminated and crescent. Whereas if you see the Ptolemaic system, that is in which Earth is at the center of the universe and planets are going around, then you will never see Venus something like this. It is a disk like this. Okay, it will always be that crescent shape, and you should, I mean, you through your telescope, you should see Venus always as a crescent shape. And this is exactly what Galileo went on to discover. So what he did was that he pointed his telescope towards Venus, and indeed he saw phases of Venus, and then he was sure that what he has seen is correct. But Galileo was a very fantastic, true scientist, so he did not discover, he did not tell the world his discovery, but actually he waited to see complete sequence of phases of Venus. And so what he did was that his discovery, he wrote down, I am not sure whether that anagram is there in this particular slide, but I can find out. But he wrote down an anagram. Anagram is a set of letters which make one particular sentence. Then that is the secret, and that secret is decoded into another sentence using same numbers of letters. Okay, so that is anagram. Let me just check whether I think it is repeating. No, I think I'm repeating the slides. So let me be here only. Okay, so he wrote this anagram, and then he sent it to Johannes Kepler to say, I mean, he kept his discovery secret with Johannes Kepler. Johannes Kepler tried very hard to decode it. So what that anagram in his language said, that I have prematurely discovered something about the beautiful planet Venus. And then when this anagram is decoded, when you decode this anagram, it says that Venus shows phases like moon. So he talks about Venus shows phases like moon. And this particular discovery, or this particular observational discovery, was a great proof that the planets are going around the sun. So we have discussed this, so I will skip these 3 slides. Okay, but yeah. So having said this, now let us see how this impacted our understanding of our solar system, and that is a very nice story, and we should remember. You see, Jupiter's moons was talked by Galileo Galilei, but you needed something else, and that is the Venus's phases. But once you have accepted the theory of Copernicus that the planets are going around the sun, then getting distances to the planets have become extremely easy. Extremely easy in the sense that now you can find out distances to the planet from the sun, and this is how. Consider this is the orbit of Venus. Venus is going around the sun, and this is the orbit of Earth. So for the time being, what we will consider is that Earth is stationary and Venus is going around. And for this particular discussion, it doesn't matter if Earth is moving or stationary, because we are going to talk about the angle. So what you see here is that when Venus is at the maximum distance, or that is angle between Venus, Earth and Sun is maximum, the Earth and Venus line, Earth-Venus joining line is actually tangential to the orbit. And then at this point, the angle is maximum. And what you see is that similarly, when it is maximum, the Earth Venus and Sun angle is 90 degree. This is 90 degree. So now what you have is a right angle triangle. Now you can do two things. That is, you can use sine equation. So sine theta is Vs, that is Venus Sun distance, divided by Earth Sun distance. Okay, and if you take Earth Sun distance to be equal to 1, some unit 1, then you can find out that you can get the distance between Sun and Venus, and which comes out to be approximately zero point 0.7. So now looking at this particular observation, I told you that you can find out the maximum angle between Venus and Sun is 47 degrees. So you can actually put sine for you can put this 47 degree, do this little bit of calculation, and you can arrive at the distance of Venus from the Sun in terms of Earth Sun distance. Now, if friends, if your students are school students who haven't done trigonometric exercise, even then it is okay. What you can do is you can ask your students to draw a straight line, say, which is approximately, which is say 100 millimeters or 10 centimeters or 20 centimeters. Then draw a angle which is 47 degree. Okay, and then ask them to draw perpendicular on that line and ask them measure out this particular distance. It will come out to be 0.7. So this is how they got it. And before I proceed ahead, I must also tell you that for outer planet also it is the same thing, but right now we will not discuss a very similar method for finding the distances. So the observations of various planets give the following distance of the planet from the Sun. Okay, so Mercury is 0.4, Earth, Venus is 0.7, Earth is of course 1. Then Mars is 1.6, Jupiter is 5.2, and Saturn is 10 times the distance between Earth and the Sun. Okay, so which is what you can see, that this is if this is somewhere here is Saturn, then this is half the distance, which is where the Jupiter would be, and then what you see here is that Mars somewhere here, Earth somewhere here, then there is Mars here, okay, and then Mercury, Venus, and Mercury. So what you see here when you do this kind of a picture, what you see is that the solar system which we had drawn before, that concentric ring, it is not true. Actually, as you go away from the Sun, the distances of planets start increasing. And this is another interesting exercise which students seem to understand or realize, that how big our solar system is, how empty our solar system is. Okay, Earth it is. Earth is the only planet which has a life and which has a good kind of atmosphere. It has a lot of water. Water possibly came from collision with a lot of comets falling onto Earth. I just saw my time, and I am really running much beyond lesser time. So let me quickly skip Earth. But here is another interesting exercise which I would like to share with you. See this particular picture, which is taken from Apollo astronauts, where often poetically people write that the Mother Earth is rising over moon. Okay, it is rising or setting. But think about it. You can ask this question to your students. That is, can you, just like way we see planet, sun, star rising and setting on the Earth, from the Earth, can you see this Earth rising or setting on the moon? Actually not, because we always see one face of moon, one side of moon facing towards the Earth. So if that is what is facing towards the Earth, then the center of the moon will see Earth right overhead. And like in this particular picture, which is on the edge of the moon, so you see the Earth closer to the horizon of the moon, but Earth will neither set nor rise, which is not 100% correct, because there is what is called the small liberation, but that is too small. Earth will be just slightly changing its position around same time, but Earth will not be seen rising or setting. But what you will see is that phases of Earth as seen from the moon, that like this is a gibbous phase. And very interestingly, the Earth will rotate. You will see Earth rotating in its on its axis once in 24 hours. So that's a beautiful thing. It's a mental exercise, a mind exercise which you can do with your student. So in this case, suppose you are located on this part of the moon, then Earth will be close to right, Earth will be right overhead. If you see Earth from any of these horizon, these edges of moon, then Earth will be seen close to the close to the horizon. Now this picture shows you craters of moon, craters and valleys and all that's on moon. It's an amazingly beautiful object, and you can see through the telescope. And what exercise you can do is that you can ask them to measure the angular diameter of the moon, measure out the diameters of this crater, and convert that angular measurement into the linear distances. So students can actually find out the physical sizes of these various craters. Then we have Mars. Mars is a beautiful red planet, and people thought that at one point in time that possibly it has it has life, but today we know that we haven't yet discovered any form of life. But Mars has two moons, which are Phobos and Deimos, and Phobos and Deimos, which are the two satellites of Moon. Now this is where, again, if I can't complete the entire solar system, it doesn't matter, but I would request you, all of you, to take this particular note, because it's a very interesting point in history of astronomy, where we talked about the distances in the solar system. Now there were two
Aravind,
people.
1 minute.
Haji, yeah.
You have time up till 4:30, so.
Oh, okay. No, okay. So what I'll continue with this,
Yeah.
and then discuss some observational. Anyway, I've been discussing some projects, so I will discuss those observing projects in later part.
Yeah.
Okay. Thank you so much. Thanks a lot. Okay, I'll continue. So friends, please make this note. You will find it elsewhere. If you have not found it or you don't know, this is a very interesting exercise in mathematics, which was done by Johannes Daniel Titius and his friend John Albert Board. Actually, this person, Titius, actually discovered a mathematical rule to find the distances of planet. And it has a, as I was telling you, that it was a nice point in history where these things were done. Remember that it is 1766, and Galileo had pointed his telescope toward the sun more than 100 years ago. 1609 he had pointed, and then this is after that. Okay, so what was that rule? By the way, just to make it, just to tell you that though Titius discovered the rule, it was Bode who actually made it very popular in public, this particular rule. And see what that rule is. The original formation of a distance, original formulation for distance A, that is the distance of planet from the sun, was as follows. You take A equal to n plus 4 bracket close divided by 10, where n takes value 0 and 3. So you remember to write down 0 and 3. Rest of the numbers you don't have to really remember, because it's a 3's double is 6, 6 double is 12, 12's double is 24, and so on up to 192. So that is Bode's rule, and see how it matches with the distances of planet from the sun. So you see here that for Mercury, which is 0, it is 0.7. We saw it is 0.7. Okay, Venus is 0.3. Mercury is 0.4. Venus is 0.7. Earth naturally would take value 6, so it will be 1, and so on. Except that there is a gap here. For a value of n equal to 24, which comes out distance about 2.8, there was a gap. So people did not pay any attention to this particular gap. Okay, this is an interesting gap, but no one really paid any interest. Okay, they said, okay, fine, there is a gap, but no interest was paid. Then what happened was that on 13th of March 1781, this great person, Sir William Herschel, he was observing and he observed an object, okay, and he reported it as a comet. You can see it took quite some time for him to report this as a comet. He first observed on 13th of March, and then actually reported much later on 26th of April that he has discovered a comet. Now, by this time, the rules of planetary orbits have been talked about by Johannes Kepler, and it was known how the planets going around in the elliptical orbit. So, what people did was that people started trying to find out the orbit of this particular comet, and the method of finding comet orbits of comet and planet was had become known, mathematically known by them. So he tried to people started finding out what is the orbit of this comet, and do whatever you may, you will never solve that orbit of this comet. What I mean by solving the orbit, that if you consider, comets are generally considered long elliptical or parabolic. So if you put that kind of values and equation and trying to solve for parabolic or long elliptical orbit, the orbit was not fitting, then observations were not fitting, and so on. And this object was there in the sky. It was followed. So then finally someone put the orbit of planet. They try to solve this equation. So that is observations into equation, okay, and try to solve this problem. And they found that, oh, actually this particular object fits very well as a planet. And this was the first planet which was discovered by the mankind. So he had discovered the first planet, and which was later on named Uranus. Okay, that is the Uranus's discovery, the story of discovery. Then they wanted to. There is another history that he wanted to name after someone, and then and so on. Okay, but let's not go into that. But interestingly, the position of Uranus. I'm sorry, I think there is. If you can see the value of Uranus, 192 is 19.6. So what you see is that Uranus actually, orbit of Uranus or distance of Uranus from the Sun, okay, fell exactly into the next planet in the TTS board's rule. And then there is an interest among the scientists that they thought that this particular rule has some value, and there must be a planet between Mars and Jupiter at about 2.8 astronomical unit, that is 2.8 times the distance between Earth and the Sun. There must be a planet. It was such an amazing thing that once they had discovered Uranus, then there is an interest in discovering this particular lost planet. And what the person who started this search for lost planet, or planet which was not seen, was Baron Franz Xavier von Zach. He what he did was, is assembled a group of 24 astronomers. He went to various places and said that, look, this is it, and what we need to do is that every one of us should take one part of the sky and look for this object between which moves, which is at 2.8 astronomical unit from the Sun. So how do you find this particular object? Interesting it was. Okay, the task required. So what they did was that every astronomer had this, what is called the hand drawn. You see, that time printing was not so much, and hand drawn sky charts were made, prepare for all the stars in what is called the zodiacal band. What is a zodiacal band? Is the path of the Sun across the sky, and all the planet being closer to the same plane in which Earth rotates the Sun. So all the planets are also can be seen, or are seen generally closer to what is called the ecliptic band. So the planet would be seen, if there is a new planet to be seen, it will be seen in somewhere in that region only. So these were the star maps were made. Okay, zodiacal band were agreed. They agreed to some kind of a limit, which is something like 9th magnitude or 10th magnitude. I don't recollect that. And then they had to find this object. Let me see. No. So since I seem to have missed out that particular slide. So what I wanted to, or do I have that slide? No. Can you see the complete screen?
No, your slide has gone. Means sharing has stopped.
Oh, okay. So let me share it again. I just wanted to see whether I had. Okay, 1 second. Sorry, friends. Very sorry for this. Let me get this picture. Uh, and share. Has it come now?
it's coming. Yeah, it's there.
Okay. Okay. So, how they were to know that this is the object? Okay, so I could not. I seem to have missed out that particular diagram from this PowerPoint presentation. The diagram was that the planet at approximately 2.8 astronomical units from the Earth or from the Sun moves about 1/4 of a degree in 24 hours. Now you see 1/4 of a degree in 24 hours means how much? If you take the diameter of the sun, angular diameter of the sun, which is a half a degree. So if you find an object or asteroid or some body which moves by that particular amount, then that body is possibly your missing planet. So they were looking for this missing planet, and these all people were observing. But interestingly, this particular gentleman, Giuseppe Piazzi, was not part of that team. And please remember, or I must tell you this, that at that time in this history, that is about 1800 or so, beginning of 1800, Giuseppe Piazzi had one of the best telescope, or possibly the best telescope in that region, or the best telescope in the world. And he was an astronomer, but Zach Baron had probably or decided not to include, miss out, or whatever, for whatever reason. But he was not part of that team of 24 observers, whom they called themselves as celestial police. So they called themselves celestial police because they are going to find this particular culprit or missing chap. Okay, so it was, so Giuseppe Piazzi was observing on the night of 31st of December 1800, and then on the previous night of 1801. Okay, and then he discovered this stellar object just exactly the way it was described. First, also he also thought he has discovered a new star. Okay, and then he started observing the new star, but then it had moved exactly how much it should move, and then this new star, he called it new star, and finally it was realized that it was not a star, but it was another planet. Now forget about what asteroid I have written right now, but it was a, he called it as a planet because it had all the properties in the sense that its orbit was exactly like planets. So he called it a new planet, and it fitted exactly at 2.8 astronomical unit. Now today we know, or soon after that era, people knew that this object which Giuseppe Piazzi had found was not actually into the realm of planets. You see, it is not exactly planet. It was not bright. It was discovered using a telescope. It was rather too faint. Okay, and then they called it asteroid. Asteroid means, aster means star. You have seen aster flowers also, star-like flowers. So it was called aster, a star-like object, and that is asteroid. Okay, and as you saw here, as you see here, that exactly fitted into this particular sequence, and now they found that this TTS board law or rule has some kind of a physical significance. Now talking about asteroids, so later on over some period of time, people started finding more and more more asteroid in this particular region, which is up 2.8 astronomical units, and these asteroids are called main belt asteroid. There are about 100,000 known asteroid within this belt. Then there are more other asteroid. Okay, but people debated whether these asteroids are, what is the nature, or why you have so many asteroids in this particular region. And at one point in time, they thought that possibly there was a planet which broke into a large number of pieces for some reason, and these pieces are orbiting the sun. Okay, these pieces are rotating around, going around the sun, so it's possibly a broken planet. But today, astronomers also know that or scientists have realized that if you take all the known asteroids which are known, or possibly all these asteroids which are brought together, it will not make an object as big as moon is. So there is hardly any material to make a big planet. So what astronomers now believe is that these objects were formed at the time of a solar system, and they did not coalesce to make one full planet, but all planets, similar small planets which are going around the sun. Okay, and the largest that what we saw is Ceres, and what you can see is that Ceres, because the CP Piazzi from Sicily, and the goddess of Sicily is Ceres, so it was called. It is named after the goddess of Sicily. And this series itself has 30% of total mass. Now, why I was also telling you this is that planet story is because later on in 2006, Pluto, which was called planet, was dethroned from planetary position, and new category was made, which was called the dwarf planet, and now Ceres also is also a dwarf planet. Okay, so we go to Jupiter now, and I told you about Jupiter. Now, in case of Jupiter, I would also like to tell you something, that how methodic and how systematic this gentleman was, who we know as Galileo Galilei. Galileo committed everything that he observed in writing. He kept a wonderful diary, wonderful logbook in which he wrote down everything that he saw. So whenever I gave a talk to young students, I tell them that don't remember, or don't commit to your mind, but commit to a paper, because what you remember, what you think, what you thought can change over a period of time. Your memory may fade, but what you write down on a sheet of paper will remain for long period of time. And if no sheet, you can actually you don't feel like writing, you can have your own internet, or Google Doc in which you should write down. So friends, please tell your students to, whenever they take observations, don't just keep remembering in your mind. Whatever you see, you should write down. So when Galileo Galilei saw this, when he pointed his telescope towards the Jupiter, towards the planet Jupiter, he saw two more objects which were following it, and then he kept a very systematic record of all these planets. And then when he plotted their position, it came out that he said that these must be the moons of Jupiter, and this is how Jupiter is seen from Earth. Now, this is not there in the exercise which I am telling you, but one of the wonderful exercise which can be done at the school and college level, or particularly amateur astronomer and college level, is to find the speed of light. You see, by about end of 1600 and beginning 1700, where there was a Tycho whose observations were used by Kepler to get the orbits of that is previous to close to contemporary of the Galileo and Kepler and all that. So he made this Tycho. So in Tycho's family, there was this gentleman called Romer. His name was Romer. So Ole Romer, who found the method of finding the speed of light. Now, what was the method? Is that Jupiter is so far away, so you can actually observe eclipses of moons of Jupiter. That is, the moons which are orbiting the Jupiter, sometimes they go inside the shadow of Jupiter, or they come out of shadow. So if you can actually time the eclipses of moons of Jupiter, then you can find out the speed of light. I will not go into the details of speed of light, but you can use this method to find the speed of light. Ole Romer first found out the speed of light. Now, this image is also a beautiful image where it shows that there is a moon of Jupiter somewhere here. It's a moon of Jupiter. This might get lost in the transmission. The image is rather too close to Jupiter's color, so may not be seen, but you possibly can see shadow of moon of Jupiter. This is another interesting phenomena which can be seen in the sky when you point your telescope to Jupiter, that you can see sometimes that shadow of moons of Jupiter on the Jupiter disk. Jupiter also has this particular thing which is called the Great Red Spot, and which has been there for many many years, at least 300 years, where people have seen why it has come, how it has come. No one knows, but it has been seen. And then again, another exercise is that if you measure the diameter, linear diameter of Jupiter, so Jupiter is about 10 times the size of Earth, so you can make out that this particular Great Red Spot is approximately two and a half times the size of Earth. So you can imagine what a big tornado that Jupiter is having, and it is continuously working. As you can say, it is, see its pictures which are taken. The shape is continuously changing, but it has not diminished. Then we come to this beautiful planet, which is Saturn. Okay, and Saturn shows the rings, and this is a nice object to see through the telescope. And to give you a comparison of Saturn's ring, is that this particular picture is what is called the Saturn being occulted by the moon. So what is happening is moon has come directly between us and Saturn, it has covered nearly one-fourth of Saturn and quite a lot of half of its rings. Okay, so you can see that this is the angular diameter of moon, and this is the size of Saturn. So that is that small that Saturn is, but it is amazing planet. You can see beautiful rings. Now talking about rings, people debated that what kind of rings Saturn has. Okay, and then astronomers were talking about it. Then Gauss, I think he said that the rings of Saturn cannot be a complete disk. Okay, mathematically it's proven that gravitational forces and other forces will break that disk into a large number of small particles, and the rings are made out of small particles, icy material, and that is how the rings of Saturn are. Now, this was the theoretical explanation and theoretical understanding of the rings of Saturn at the time of beginning of 21st century. That is we're talking about last century, the 20th century, and rings were seen. So how do we? But they were never really observed at that time. Rings were never really observed through telescope as being separate entities. And then what happened was, one night it was predicted that Saturn will be occulting a bright star, a star which is far away. So Saturn will be coming between Earth and that star. And a few amateur astronomers they saw that star. They pointed the telescope to that particular star, and they saw the star actually blinking through the rings. And they said that yes, so rings cannot be one complete disk, but it is a ring is made out of large number of small particles. So then we come to Uranus. As I told you, Uranus was discovered by William Herschel on 13th of March 1781. Okay, and Uranus, when you see it, is a very flat disk. It has a methane. But here again, now I want to tell you one more story, and that is very close to our lives. Most of you are probably of the age where I think it was 1975. I think 75 or 77. Sorry, it was 77. Again, it happened in month of March. So it was predicted that Uranus would be occulting a particular star, and astronomers gathered together, and there were astronomers from Kavlur Observatory and of Indian Institute of Astrophysics, Professor Bhattacharya, another my colleague Kupuswamy was there on the observing floor. And what was done was, the star was looked by what we call a photometer. So there is an instrument which detects the light, and then that light is fed to what is this strip chart recorder. Now the story is like this, that you have seen, many of you might have seen going to a doctor for your heart check, right? So they put a lot of small probe on your body, and then traces is taken on the sheet of paper. So now if the trace is regularly going, then your heart is okay. Here it was a different thing, that the telescope was pointing towards the star, and similarly stresses were taken. Now in today's era, it is all electronically and digital, so the numbers are recorded into computer. But in those days, it was the strip chart recorder which was observing the, or which was taking the observation. And the sky was beautifully clear, and there was nothing to say there is that would affect the observations. And then, prior to the observation, see why they were observing is that if there is a star behind Uranus, then sorry, as the Uranus occurs or blocks that star behind, and if Uranus has a ring, sorry, atmosphere, then that star would blink, and we will get to know how thick the atmosphere is. But what happened was, a few hours before actually Uranus would occult that star, the needle started wavering. Now, needle started wavering is a good enough indication to give to lose astronomers to astronomers to lose their mind. And immediately Kupuswamy saw that the needle was flickering rapidly. It went down, it came up, it went down and came up, and it was vibrating. And so everyone on the observing floor, whoever those people were, they started checking whether there is a loose connection, whether there is a problem in the power supply, whether instruments are right or not. But sure enough, after a few minutes, the line became steady. You see, in human case, if the line steady becomes steady, means you know what happens to that human, it is gone. But here, the line became steady, and all the heart was put back to its normal position, because no instrument was not wrong. And then they finally concluded that this particular observation tells you that there is a ring between Uranus, there is a ring which is going around the Uranus, and that when that ring came between the star, distant star, and the observer, the needle flickered, and that is how the rings were discovered. And this particular discovery was considered to be the discovery of that particular decade. So rings of Uranus were discovered by observational method. Now we come to another step in our discovery of solar system, and that is discovery of Neptune. So discovery of Uranus was telescopic. Discovery of Neptune was actually mathematical. What had happened was that when they found Uranus going around the sun, okay, so they started making predictions, but no prediction would fit accurately. Whatever they tried, the Uranus orbit was not coming out properly. Then two astronomers had this particular idea in their mind, and they said that possibly uh, there is a planet behind, away from Neptune, okay, away from Uranus, okay, that might be affecting Uranus's orbit, okay. And who are the players? There were this Urban Leverrier in France. Okay, he made the calculation. There was Douglas Adam. I think, yeah, the Douglas Adam. He was in English mathematician. Unfortunately, we have the only. This is the picture of Douglas Adams, and there is nothing more is available. And this is where the interesting human story plays role. You people probably might have heard Aries disk, okay, in case of optics, where if you focus something, then it is not one focus, but there are rings around it. It says the diffraction pattern and so on. So that was Aries. I think Aries was Astronomer Royal, and this man had just finished his tripos examination. It is a tripos Wrangler's examination, and he also arrived at the same point. Actually, Adams and Leverrier, they arrived at the same idea, that if there is a planet beyond Uranus, and that planet is affecting orbit of Uranus, then mathematically they can predict where Uranus is. So that predict where that new planet is. So Douglas wrote his theory, and he went and gave it to Aries. Okay, Aries, who was the director. Now, he was just about 19, 20 years of age, and not known to people. And this particular, his work was just left unseen. Here, on the other hand, Leverrier also, Leverrier's fate was not very different. The French astronomers also didn't bother, but Leverrier had another friend who was more ambitious, and he told Leverrier to do the calculation. And when he did the calculations, he asked his French friends to look for this object beyond Uranus, and they didn't bother too much about it. And so then what he did was he sent his observation to his friend Gall, who was in Germany. Okay, not too far from his place. So he sent his observation. He sent him a set of data in which the date and the position of this unknown object was marked. Now he was John Gottfried Gale, who was Gall. He was in Berlin Observatory. That picture that you see here, and it was sent to him. Now the story also doesn't end here. So Gall, what he gets the observation, he takes his assistant and say, okay, let us go and find out this object. He had clear sky also, so they go to the observing terrace here, observing floor, point the telescope to that particular object, and they don't find anything. So then his assistant says that, sir, now that we have looked into, we have just received a new set of star maps. So why don't we refer to this new set of star maps and check it again? So they do that and check the positions sent by Leverrier at that for new planet, okay, whatever it is saying, and they, sure enough, they find this particular object. This is the new set of star map, original Brahmaiker star map, okay, which Gall and DRS found, and then this is okay. This is where they found. Sorry, this is where is the position, predicted position, and this is where they found this new object. Okay, and then he immediately, not immediately actually, but he observed for a couple of more days and sent back this data to Leverrier, saying that see, we have discovered the object that we found. Now a major battle or political battle was played, because French have beaten the English, and you know that French and English, they have always, there is a kind of a tussle between them, and then English people French people announced that we have discovered. In the meantime, Aries got to remember that there was such kind of observations. So what they did was they started searching old photographic plates and to try and find out this missing planet. And it's a very interesting again that on two plates where actually Neptune was registered, but they missed it out completely. So you saw this. See the story. Then I would like to narrate to you, or rather, I'm trying to tell you, is that if your assistant or junior student comes and tells you something that he or she has found out, just don't dismiss it just because that person is not known. Possibly that person has really discovered something new. Some bright person, you may not have noticed it, but might have found something entirely new, and that would bring loyal to your organization. So don't miss it out, because this gentleman, had he taken Gall's data or Gall's observation and look for the planet beyond beyond Uranus, they would have certainly discovered Neptune. Then there was a lot of fight between those astronomers during that period of time. French said nothing doing. This is discovered by French astronomer, and this is the French discovery. But today, astronomy, the time has changed. You saw this about 100 years have something of that nature has gone. So today, astronomers give credit to both these young people who did this difficult mathematics to arrive at this new planet. Now we come to the last part of it, where you have Pluto here, and Pluto was discovered. Pluto was discovered not by any method, but a very difficult task of what is called the blinking of photographic plane. Pluto was discovered, but Pluto does not fall. Actually, Neptune does come very close to TTS board law, but Pluto is very far away. It is off by 90%. And as we come to Neptune is almost 30% off from the real value, and this is about 100%. So now people don't believe in TTS board's rule, but though there are mathematicians who try to calculate something like that, but TTS board's rule is no longer valid. So that is our Neptune, which was discovered. Neptune is a um, Roman mythology, god of sea. And then you might, older people would remember probably Poseidon Adventure. It was called that, where the ship was sunk and so on. So I will not go further into Neptune. But coming to our solar system, so now what we have is the sun in the center, and these are the planets which is around, rotating around the sun, and Pluto, which was called a planet at one point in time, it is no more a planet because Pluto's position, uh, Pluto is too small. As I was telling you, Pluto is too small in size. Then its orbit actually comes inside the orbit of Neptune. Okay, and therefore in 2006, astronomers debated very strongly, and then a new category of planetary planets was made, which was called the dwarf planet. But they haven't yet given complete properties of dwarf planet. What they did was that they gave the properties of what you would call planet. And what is a planet is then a planet which is contracting on its own gravity, that is on its own gravitational force. It becomes a spherical, and then ellipsoidal because it is rotating, so it will bulge in the center, but it is spherical. Then a planet, sorry, a planet which is orbiting the sun, and there are no more object in that particular orbit, so it has cleaned up all the material in its orbit around the sun. And lastly, the planets do not cross each other's orbit. So that is the definition of planet, which is called dwarf planets. Are the other planets which are not asteroids and planets. So these are dwarf, but people are yet to arrive at complete definition of dwarf planet. So that is Pluto, and Pluto has a companion, which is going. Actually, Pluto is a system of few more objects. But talking about our solar system, I will just close it by saying that there are also comets. The comets which come from far away object, distant object, they have a open, they are a parabolic path. That is the ellipse which has its one foci kept at infinity, that kind of an orbit. Okay, so the comets come from far away distances. There are some comets which repeatedly come, so they are called the periodic comets. There are some comets which come once, some 30,000 years kind of orbit they have. So these are comets, and comets are nothing. What is called Fred Whipple was an astronomer who called them as dirty ice ball. So they essentially contain a lot of water ice, carbon dioxide, silicates, and this is a nice tight ball, which is in a very frozen state when it is away from the sun. But as it comes closer to the sun, the sublimation process of sublimation, in which these material from solid state goes into the gaseous state, so it sublimates, and initially it has just a envelope of this gaseous material, and then as it comes towards the sun, this material is thrown away from the sun, and this object develops tail. And actually comet gets its name from what is called the stella coma. Coma is hair, stella is star, so stars with the hair is called the comet. So that is the comet. Now one last point about the comet is that there was a comet which was seen and which was noted, and it broken into large number of small 21 pieces. Many of you might have seen this. Okay, many of you might have remember observing this, which happened in 1994. So another little story which is associated with this particular event is that in 1994, beginning of 1994, the world was open to internet, and Ayuka was one of the places where internet facility was given. So I remember during that period in 1994, when we saw that comet is going to collide Jupiter, so normally something for the newspaper, something which would take about 24 hours, we just got this picture, and the same night we could give it to the newspaper. So these pictures were taken by Hubble Space Telescope. But the point I was trying to tell you was that when these pieces collided with Jupiter, at one point people thought that possibly the great red spot, which we had which we talked about some time ago. Okay, so great spot might have been made by comet particles impacting on the Jupiter, but this impact signatures, which did not last for too long, and these features have vanished. So the great red spot may not have been the impact of a comet on Jupiter, because as you see here, the sizes are not very different from the great red spot. So they were very large size, about Earth and a half diameter sizes of these objects. Okay, so now coming back to our entire solar system, so this is where I would like you to pay some attention and talk about. Do I have? Yeah, I have the model. So here is a general table which talks about the sizes of solar system, density. Yes, one thing which I forgot to mention about Saturn is the density of Saturn is less than 1, or means that Saturn is the only planet. If you had a large enough water body, then Saturn will not sink, it will float on that large body. Then Earth is the first planet in the solar system which had moon. Now this is an old slide. Jupiter's moon have gone more than 50 and so on. But basically this is telling you the sizes and their average distance from the sun. Now here comes a very interesting project which you might like to take it. See, the data about the diameters of planet and their sizes is very easily available for everyone. So if you look at the internet, there is this site which gives you a solar system model interactive size, okay, interactive site, where if you put in these bracket, this is in inches and this is in millimeter. So if you put either of these two into the window, then what you will get is that with this as a scale, you get the entire scale down size of the solar system. Say for example, if your sun diameter is 150 millimeter, then what you find is that Mercury is 0.5, Venus is 1.3, 1.3 Earth, then Mars is 0.7, Jupiter is 15 millimeters in diameters, and so on. And then these are their distances. So how we use this model? Now I have used this model for the students, and this particular model is extremely good in telling them about the science and debunking astrology. And maybe I think we all are science enthusiasts, and we would love to debunk astrology. So let me spend a few minutes on this particular thing. See, what I do is, with our student, I ask them to find out the diameters of the planets, also their orbital radius, how far their radius is, and then after doing that, we say that take sun as a sun as a diameter of the one sec, huh? Okay, take sun diameter equal to 150 millimeters and find out what are the sizes of various planets. So here, this is the table from where you can find out where is the size. Now, as a next step, we ask students, so tell us, okay, it is 0.5 millimeters, right? So can you tell me a physical dimension which has 0.5 millimeters? By the way, why I chose 150 millimeter is also because in your geometry box, that small scale is 150 millimeter. So you can visualize how much is 150 millimeter is. So I say, okay, so now what is the 0.5 millimeter? So our clutch pencils, the clutch pencil lead is so very accurately 0.5 millimeter. So we have two types of pencils, 0.5 and 0.7. So you can see that this lead diameter can be represented by one type of so Mercury and Mars. Then how much is the diameter of Venus? Okay, Venus diameter comes out on this scale 1.3. Can you visualize what 1.3 is? Children generally can't visualize. Then what we do is, what we tell them, that take mustard seeds, okay, and try and measure their diameters. So how do they measure the diameters of mustard seed? If you tell them, they come up with the various ideas that you take a rope and turn it around, and then you have circumference, so you can find the diameter or cut it and so on. And then you know that how to cut that small particular piece. But what you can do is put 10 mustard seeds in a row, measure their length, and divide by 10. then take 20, then take 30. And by doing this repeated exercises, you can find out the approximate or mean diameter of mustard seed. Now, if you see a normal mustard seed, that comes out to be large, approximately 2.2 millimeters in diameter. Means even larger than diameter sizes of Mercury and Earth on this 150 millimeter scale. Similarly, it is Jupiter 15 millimeter, that 25 paise coin is about 15 millimeters, and so on. So now you have these numbers, and what you see here is that Pluto is even smaller, zero point 0.2 millimeter. Now come to the next thing is that you find their distances. Okay, Mercury is 6 meters from the Sun. So how much is the 6 meters? So what we do is we ask students to walk and find out what their step length is, and convert that you ask them to walk how many steps you should walk in order to reach 6 meters. But there are other examples in your classroom, like for example, desk is generally 1.5 meters. Okay, so you can put it 5 desks and 3 desks to make it 6 meters. So that is the distance. So if you keep your scale, that is 150 millimeter diameter circle at the glass board, then where should you walk in order to put Mercury, which is 0.5 millimeters? Then Venus is 11 meters, Earth is 16 meters, and when you come to something like Neptune, you are almost walking half a kilometer. So then you get the idea that how large the solar system is and how empty that solar system is. It's an amazing experience with the students, and at whatever age, I mean, I suppose you can realize it for yourself. And then I come to this particular point that imagine Jupiter, which is 83 meters, or nearly, children who do know that if you have 100-meter race, okay, so 100-meter is, you get idea that this is 100 meters. So you can tell them that, look, a Jupiter which is just 15 millimeters in diameter, kept about 80 meters away from you, and then can that Jupiter influence you and me differently? Can that Jupiter have actually effect on your body, which is because you are on the Earth, which is 1.3 millimeters in diameter, Earth itself, and how small you would be on Earth, and then is it really possible? It immediately gives them an impression or gives them an idea that Earth is too small, we are too small to be getting affected by this object. And then of course you can also tell them that, look, a person whose weight is approximately about, suppose that when the child is born, if the doctor's weight is about 100 kg, his gravitational influence on the child is more than Jupiter's influence on this particular one, baby that is born. So this entire discussion on solar system, which I talked to you, is that it is a nice example or nice discussion that you can have with your students, and also you can ultimately use it from debunking astrology. So this is what I wanted to tell. I think I would stop here and take few questions based on whatever I have discussed, if there are. Otherwise, I will discuss with you some of the observing projects, simple observing projects to be done with the astronomical telescope. Is that okay?
Yeah.
So if there are some questions or points that if I have made a mistake or something you would like to correct me, please do.
Good evening, sir.
Good evening.
Sir, it was very nice and session, and I enjoyed it well. I would
Thank
like
you.
to, sir, ask a question where you saw that Jupiter and you saw that there was a moon.
Yeah.
So the shadow of the moon. So it was the shadow of the same moon or a different moon shadow? I couldn't listen.
Beg your pardon? Sorry. No, there were 3 different moons of Jupiter.
Okay, so there was shadow was of different moon, and that moon which was appearing smaller was different moon.
Different moon. Yeah.
Okay.
You through a small telescope you can see 4 moons of Jupiter, which is what Galileo observed, and generally you see all the moons on a one straight line.
Thank you, sir.
Oh, by the way, I must also tell you before I take the next question, I wanted to share with you is that many a times I have seen students come to us and say that I want a project, I want to do this. Okay, I am interested in astronomy and I want to do some great project. And then you say how much interested you are in astronomy, and the style would say, "Oh, I want to know about black holes. I want to go know about wormholes." I think all of you must have experienced very similar thing. So what I do is immediately when someone says, I said, "Okay, fine. You are interested in astronomy. I am very happy, but tell me what is the orbital speed of Earth in its orbit?" And they immediately say, "Sir, you are asking something very complicated question." And I tell them that, "Look, this has been taught in your 8th standard class, how to get it, because you know, if even if you don't get the correct answer, you can tell me the method. And then you have a distance between Earth and the Sun. Take Earth as a circular orbit, okay? And then how much time Earth takes to go around the Sun? It is 365 days. So how much it per day? It is 365 divided by 365.2422 divided by 360. So you know, so you can find it. So you can enthuse your student by these at-home experiments or at-home examples to really think about what. Or instead of talking about big thing like black holes or dark matter and dark energy and things like that. Okay, so I wanted to share this with you. Any other question? I will be happy.
Participants are encouraged to actually ask questions, because then only it becomes more interesting.
Or you can challenge me also. It's perfectly fine.
But
Yeah.
whether we will be knowing something about black hole or in this lecture or not, just in this range of things.
I think, yeah, I suppose there are lectures on black holes and all
Okay.
that.
So just because just to increase your listeners.
I think Mr. Dr. Ganguly can tell that.
See,
fine.
there is a session on physics of stars, stellar
Yeah.
physics. So their compact objects will be discussed. As a part of that, you will hear something on black holes.
Yeah.
Thank you, sir.
I would just at this point, because there are heterogeneous group, so can
Yeah.
you just make some comments on these beliefs in
Please.
astrology and all? I mean, I want you to
Yeah, yeah,
make,
please. I think, yeah.
yeah. So this common belief which is spread throughout the country on astrology and astronomy, can it be briefly stated? Means you can state it.
I beg your pardon. Sorry, you asked me something.
Yeah, I am telling that. Can you say something about this beliefs which is prevailing throughout on astrology, and what is its difference between astronomy and astrology and planets? Because there is a lot of confusion in, I hope, among lot of people. So,
Yeah, sure. I'll be happy. But I think there was someone else who was trying to ask question when you were saying something.
yeah,
So
yeah.
yeah. Who was it? Someone?
Yeah, I think Sarita Mishra. You are trying to ask something? No.
Friends, I have just shared with you DIY astronomy wordpress.com link, so you can go, and I have given you my email ID. Yeah, so yeah. Who wanted to? Is Sarita Mishra? You want to ask question, or should I go ahead? Okay, Fritz, talking about astrological misconception, you see, yeah, oh, go ahead, sorry, go ahead. You want to ask something? You want to say something? I think there's some audio issue.
Yeah, I think you can go ahead. That is.
Okay, so what I have found was personally that when we start debunking astrology and talk to people bluntly that it doesn't work, if you talk to them in their own language, and if you talk to them and instead of saying it that it doesn't work, you ask them to explore in their own mind, then it becomes a little more convenient or more easy to communicate. Okay, for example, when they people say that during the total solar eclipse you should not eat anything, poison comes out, okay, material, it is poisonous, so you should not eat, and whatever you have taken is you throw away. Okay, so We will in the normal thing will say, oh, nothing like that, it doesn't happen just like that, there is nothing which hurts, and you should eat. And then for myself also, every time I people ask me question, or when there is a total solar eclipse or total lunar eclipse or eclipses, I actually, whenever TV people ask my interview, I actually eat something in front of them. Then I also tell them that, look, in my lifetime I have observed so many eclipses. Okay, and I started at the reasonably lower grade at Indian Institute of Astrophysics, and I have achieved something in my life. And then we say that in Indian philosophy there is a beautiful verse that is karmandevadhikaraste. So whatever karm you give, you will get its fruits. Okay, so you forget that, and then you talk about everything else. So don't say that Indian astrology or Indian astronomy there was something like that. But then coming back to the poisonous thing, so then you will say that they will say, "Ki why people think that it was poisonous?" So the reason is as follows. See, just before the total solar eclipse, and I think Ravi Kiran, as my friend is here, will remember that when we observed during the total solar eclipse, just before the eclipse take place, you see a lot of shadow band rapidly running. And if you do not know what they are, it can be very scary. I mean, even when it was happening, you are standing there and you see a lot of waves going zigzag, zigzag, as if a lot of snakes which are crawling around you. Okay, you see that. And it happens only for a second or two, not longer than that. And it is gone. So this happens at the time of beginning of solar eclipse, also at the end of the solar eclipse. So people might have considered that during the solar eclipse, you see that in the olden days there were no communication, only few people have observed the solar eclipses. Information is passed on from one group to another by word of mouth. It is not written document. There is no proper explanation. So someone comes out and say that, look, there is no during the solar eclipses, all of a sudden snake comes, and then you associate snake with poison, and therefore your food becomes poisonous and you don't eat. But if you tell them that, look, this is what scientifically happens, and why do you see that wavy pattern? Then also you can say that, look under the swimming pool when there is no person swimming, and see on the swimming pool bed, and you will see this zigzag pattern. This is atmospheric phenomena. This is generating this kind of a wavy pattern. So once they know this, generally people don't. People do accept it, and when you explain that, people tend to accept whatever you have said. The other part of astrology, I will tell you that every newspaper carry this days prediction, weeks predictions, months prediction. Okay, I have a very nice example. In Ayuka, we used to conduct what is called the school student summer program, and we had in the bracket a wonderful astrologer. He could predict that what is going to come in tomorrow's paper. Okay, you might find it funny, but this boy said that I could predict what will come in tomorrow's paper under the astrology column. So what has happened is that this boy, over a long period of time, collected all those astrological predictions. Okay, then he filed them, and after some time he found that the person who is sending this prediction is not actually generating it every day. What he is doing is cyclically he is flipping his predictions, and so he know tomorrow what prediction he is going to print. So he said, I have such example. Okay, but the jokes apart, it is true that people have these predictions. So then what is the example, how we can tell them that to believe it or not? I have this example which is that, look, in astrology, suppose your Rashi is Leo, Siha Rashi, okay, and they say that Siha Rashi would have accident. Today it's a bad day, you are going to have an accident. Then did these astrologers went to the hospital to find out how many people admitted into the hospitals who were of that sign, sunshine Leo? They never do that. If they have made a prediction, it is their responsibility to go and check whether their predictions have come true or not. They don't do any such thing. Okay. The second thing we said, tell them that during the, talking to astrologers, we tell them that, look, you can't, their general argument is that you can't fix the birth time, right? They can't fix the birth time because they don't know whether it's a conception, whether the child coming out or the umbilical cord being cut. They will give that kind of argument. But when you have an accident, particularly air accident, where everybody dies in a fraction of a second, so get their horoscope and see if you can calculate it back. Can you now calculate it? They will not do that because they themselves know that it doesn't work. Actually, if I am a scientifically acclaimed astrologer, my first task would be to collect this particular data and then do mathematical prediction about their birth. But astrologers will not do that. The third thing you can tell these people is that go to an astrologer, you don't mind, but ask an astrologer to write down your prediction on a sheet of paper. Like, you go to the doctor and doctor writes a prescription. So ask this astrologer that you write a prescription, and today in many parts, many doctors, they also write underneath a line that no medical advice is 100% correct. There is a possibility of changes. Okay, they're right. So we can also tell astrologers that okay, it doesn't matter. You do this and you write that my prediction may not be 100% correct, but write something and give it to me. Will they do it? They will not do it. And therefore, I can talk about many such examples about how to counter argue. You have to ask your clients, I mean, that is your audience, that go and ask these astrologers to do it. Will they do it? If they don't, then why do you want to believe in astrology? Then third question is that people generally say that comes a question from audience, a general audience. Then why do you think our Rishi Munis, they talk about astrology? Astrology is such an old science, etc. First of all, remember, astrology is not Indian method. It has been imported from Greeks. Indians were not astrologers. It had come from Greek side. Okay, not Indian basically. Okay. The second part is that if they do astrological predictions, then on what basis? So we also say earlier days they used to talk about, astrology, we have so many variables. We have 8 planets, 9 planets, Rahu, Ketu, and all sorts of humbug they will tell you. But today you can tell them that today the sun machine has far too many variables with which they play compared to your astrological thing. So write a program and get it corrected. What's stopping you from doing that? But they will not do it again. So same thing about any other astrological predictions. But then on a lighter note, we are almost close to end. So on the lighter note, let me tell you, I have known another very interesting person, a doctor, who could predict whether the newborn child will be a male or a female. And this is to tell you about sharing two stories about astrology. So he could predict male or female. So what he used to do was a very simple technique. What he used to do was that when the couple comes to him, say that doctor, whether our child will be boy or a girl. So doctor would, after talking for certain period of time, would know what the young couple or the couple expects, whether they want a boy or a girl. So if the couple says we want a boy, then what the doctor would tell after some time that the son will be born in your family. If they say that they want a daughter because they have a sequence of 2 sons, so we want a daughter. So he will tell them that next child will be daughter. Okay. Then what he would do is that go to his diary, and if he told the couple daughter, in diary he will write son, and if he told the couple son, then he will write in daughter. Now, if the prediction come true, they say, sir, doctor, you have told me this, and yeah, your prediction came out true. Thank you very much, and so on and so forth. But if prediction comes out wrong, then he'll say, oh, wait, let me check my diary. See, on my diary, actually I wrote, and you got a daughter only. So every time he makes prediction, it is correct. So, okay, this is a part of a joke I was trying to tell you, that this is how people would give some kind of a feeling to their patient, but nothing that would stop you. I mean, when you talk about astrology, so sorry, whatever I was telling you is that why people believed in astrology. I think my personal thinking is that why people believe in astrology, for one simple reason, is that we humans are very bad people. We do not want to take our own responsibility. We do not want to tell people that yes, I made a mistake and I will correct it next time. If I made a mistake, I will not accept my mistake. I will not own my mistake. I will blame it on the star which will not come and challenge me. That is the simplest way out. That is what we human beings do. So let us not do this, and try and teach our students to take the responsibility and lead your life more academically, more scientifically, have a scientific temperament, because that is the right path to take. Well, I've been speaking, but I would like to have your comments or observations or questions, whatever. I have gone for too long a period of time.
Yeah, participants can ask questions regarding the full talk, not only on astrology.
Anything.
Anything. Oh, I think nobody is asking any
No.
question. Okay, so
Yeah, I would only say that probably this is our first day, right?
yeah, yeah.
Yeah. So I would request all participants.
Good evening, sir.
Yeah,
Just
Vipin Kumar wants to say something.
Yeah,
Yeah,
yeah.
Vipin.
sir, I just wanted to ask that most of the time that the Hindu panchangs, which are coming mostly,
Yeah.
they generally have correct predictions for solar or lunar eclipse.
Correct.
So, I mean, could you enlighten us that how they are able to manage those things?
Okay. See, with given equations and given methods, even 4,000 to 5,000 years ago, the Stonehenge people and other people used to predict when the eclipse would take place, on what date and time eclipse would take place. So predicting eclipse is not a very difficult job. It is a tedious mathematics, and by doing that tedious mathematics, you can predict very close to it. But today's Panchang, when you talk about, not today, I mean, I'll say about 50 years ago also, there were these astrologers or Panchang makers who do a mathematical calculation, and which is a very scientific calculation. It is something to do how it is influencing. It's a complete scientific calculation by which they could predict. Even to an extent, I will tell you, there was an astronomer, mathematician, Indian mathematician, who predicted positions of Pluto. Unfortunately, in India, we only give the result. We don't talk about the methodology that we have applied. So Venkatesh Bapuji Ketkar, who had predicted position of Pluto long ago, Pluto or Neptune, okay, what are this planet? Okay, gave the prediction, but he never told us how he predicted. It is actually published in a French journal, but he never told us. Well, so having said that, so mathematics was available, and today's astrologers actually take this data from Positional Center Positional Astronomy Center, which is in Calcutta. These people do run computer programs and give the predictions of total solar eclipses and panchang and things like that. Actually, Saha. No, OSEC commission actually gave us the panchang. I mean, a reform committee was there, and the committee came up with a different panchang, which is what we are using, the national panchang. But this information comes from PAC, that is the Positional Astronomy Center, which is in Calcutta, and almost every panchang maker uses this particular data. Actually, the more clientele of PAC is panchang makers than astronomers.
Okay, thank you, sir.
Thank you. Okay, so for last line, I will say, and I will stop. And friends, please remember that next time when if you have, you can also go ahead and tell the speaker, look, we didn't enjoy your talk, but say something, because this is an interaction between you and the speaker, and this is collectively we should go ahead, because unless you ask question, we don't know whether you understood anything at all, you understood everything, or you understood nothing. And that is what I think you should also inculcate among your students, to ask as many questions as possible, because remember that some question that you would ask, probably every other person may have in his or her mind, and because of some resistance, that person has not us. And here we don't even see your faces, only names are there. So uh, uh, make this particular a wonderful program which RSCP Calicut has started, and help them by making the next sessions, other sections, more interactive. Thank you so much. I'll stop here.
Thank you, Mr. Aravind Paranjpye, for giving such a wonderful talk. And a lot of people are saying in the chat box that they are not saying openly, but here they have said that it was a excellent talk, critically correct and all. So that was good. And as somebody, I think Vipin Kumar, as you have correctly explained, that mathematically they are correct, but the problem with astrology is more with the incorrect inferences or the judgment part of it, not the calculation part. Calculation is always mathematically correct. So with these few words, I think I hope all of you have given the attendance, because attendance is compulsory for this program. Many times it has been posted, and for the last time I am again posting it. So if somebody has missed it, please put it. And with this, I think I thank the speaker, and we conclude this session today. Yeah,
Just one. Sorry,
Yeah,
I should have said that because I had said in the group, friends. Can we get PPT, friends? I would like to tell you one thing, that some of us will share PPT, but you see what happens is when we make PPT, we take out lot of information from internet. Some of it may be copyrighted, so it is not fair on my part to hand over the PPT. But having said this, I think what I will do is I will work hard and make this PPT foolproof. That is not foolproof in the sense that it is copyright proof and anybody can use it, but it will take me some time. So right now I do not want to share the PPT, because some of the images I should take permission from the original person to distribute among all of you, and this is what will be with other speakers too. Sorry, I interrupted you. We can close now.
yeah. So that's all. So we close the session today. Thank you, and we will meet tomorrow again at 9:30 with some interesting stuff for all of you. Thank you very much.
Thank you so much.